In example 3, we're given the marginal profit function associated with the production and sales of X electric ovens, given by this function MP of X, or just P prime of X, equals to the quadratic equation you see there. That's dollars per electric oven. Remember when we talked about marginal analysis back in chapter 2? This tells you the additional profit we make by selling and producing one more item. So as X goes up by 1, as we increase the production by 1 in sales of one extra item, this marginal profit tells you the additional profit we can expect from that. And so that's the derivative of profit. First, for part A, we're going to sketch the graph of P prime from 0 to 400. Label your axis with the appropriate units and also label the y-intercept value. And if you want to use your graphing calculator for this, you can. I recommend using the window that you see there. X is the X min is 0 and the X max is 400. The Y min is 10 and the Y max is about 1500. That'll give you a decent picture what this function looks like. But I'm going to go ahead and just see if I can get this sketched out for you. It's going to go something like this. And so X is the number of electric ovens. So it says to label your axes, electric ovens. And the y-axis is your marginal profit. I'm just going to put P prime there. Your y-intercept occurs when the value of X is equal to 0, which if I plug 0 into marginal profit, I get 500. Okay, we knew this was going to be a parabola turned upside down because your P prime function is quadratic with the leading coefficient a negative number. So we expected this to be that shape. In part B, we're going to shade in the region of the graph that represents the definite integral from 200 to 300. So that means we want to locate where X equals 200 over to X equals 300, which is somewhere in this neighborhood. And the integral says that's the area that's between the curve and the x-axis. And next in part C, we're going to use the fundamental theorem of calculus to compute that definite integral of P prime. We're going to show all of the steps, which means if you were doing this for me on a test question, I want to see all of your work. The integral therefore goes from 200 to 300. The P prime function I will recopy here. And this is integrated with respect to X. That is their only variable that we have anyway. So we're going to end up getting negative 0.03 X to the third divided by 3 plus 9X squared divided by 2 plus 500 times X. This is going to get evaluated from 200 to 300. So you plug in the top limit minus plugging in the bottom limit. You're going to end up getting some numbers that look like this. 285,000 minus 200,000. So you can check your math on that. If you pause the video, you can double check that. Subtract those two numbers, you get 85,000. All right, now this is no longer marginal. This is total. This is the profit we are going to earn if we produce and sell from 200 to 300 electric ovens. We earn this much in profit from the sale of that quantity of units. Okay, so the way you're going to interpret your answer is to say something like, if production and sales increases, production sales, no, I like increase better. Increase from 200 to 300. Our profit will go up, increase, because it's positive, will increase by $85,000. Okay, so that is the profit we earned from the production and sale of the 200th through the 300th electric oven. Does that make sense? Number 4, since the beginning of 2011, the number of subscribers to a city's major newspaper has been changing at a constant rate, or not a constant rate, but changing at the rate of 500 minus the function, you see that. Subscriptions per month. Approximately how many subscriptions did the newspaper lose during the second 6 months in the year of 2011? And so that is going to take you from the start of the 6th month during the second 6 months. Let's go from the end of the 6th month to the end of the 12th month. And so we're going to integrate our function from 6 to 12, okay? Okay, let's see. Make sure our 6 and 12 are correct. So if t is equal to 0, that represents January 1st. Now, the second 6 months of the year, what is that? July through December. So we want to go July through July 1st through January 1st of the following year. And so that's going to be, if 0 is, okay, yeah. So if 0 is January 1st of 2011, February is the first full month later. Count up until July. So February, March, April, May, June, July. Yes, we want to go from 6 to 12 on that. Okay, let's do it. We're going to get 500 times t minus 1400 e to the negative 0.02t divide by negative 0.02. If you remember how to integrate an exponential. And this is going to be evaluated from 6 to 12. Oh my goodness gracious. Okay, from 6 to 12. Okay, so simplify if you want to. You don't really need to if you don't want to, but plug in the upper limit, subtract the what you get from the lower limit. I will go ahead and give you a couple of steps in between. We're going to end up getting 61,063.95 for the upper limit. The lower limit is going to give you 65,084.43. When you subtract, you get a negative answer. Negative 4,020.48. Call it about negative 4020. Okay, so what does this mean in the context of our problem? This is telling you how many subscribers the newspaper has lost. So I ran out of space. And I can't move it over. So we'll see if I can squeeze it in. The number subscribers has gone down by 4,020. That's the number of people we've lost. All right, here we go for question number 5. Glass at room temperature, 66 degrees Fahrenheit, put in the refrigerator at 1 p.m. That's at the beginning, x equals 0, 1 p.m. The temperature after x hours is changing at this rate that's given to you, degrees per hour. By how much will the temperature of the glass change from 1 p.m. to 5 p.m.? So that means we want to integrate from 0 to 4. Right? Because if 1 p.m. equals x equals is when x equals 0, x equals 0. 5 p.m. is 4 hours later. That's when x equals 4. Okay, so we're going to compute this integral. We're going to get negative 20e to the negative 0.057 divided by negative 0.057. This is going from 0 to 4. Plug in the upper limit. Plug in the lower limit, do your subtraction. I'll give you that step before the answer. So the glass of juice has gone down by 31.5 degrees. Temperature of the juice has dropped by 31.5 degrees Fahrenheit over that time span. Example 6. We have a marginal cost function provided. This is dollars per unit, right? So this is how much extra it costs to make the next unit. The fixed cost for this product is given to us at $7,800. All right, for part A, find the exact change in cost of production of this product is raised from 200 to 210. From 200 to 210, we want to integrate the marginal cost function. And we get 0.03 x to the third over 3 minus 2.5 x squared over 2 plus 150x. And this gets evaluated from 200 to 210. Top limit minus the bottom limit. I'll just give you that final answer this time around. We end up getting, put it up here, $8,985, right? Our marginal cost was given to us in terms of dollars per unit. So we have dollars for our cost answer. So this is going to be, this represents the cost of producing the 200th through the 210th unit altogether. All right, so that would be my interpretation if it were requested. Sketch the marginal cost function and show the area that represents your answer to part A. This marginal cost is going to be parabolic because it's second degree function. It's going to open up because leading coefficient is positive, and it's going to cross the y-axis rather at 150. So if you wanted to try to sketch this on your calculator, I've given you the window that you see there, but that's the general shape. The 200th unit is somewhere in this neighborhood. The 210th is just a little bit over towards the right. And so the shaded area is the definite integral that we computed in part A. All right, for part C, find the cost of producing 210 units. Find the cost of producing 210 units, all 210 units from the beginning when you've opened up your factory doors all the way to production of the 210th unit. What was your cost in doing so? In this case, we want to know the integral of the cost function, the marginal cost function, which we found up in part A, but this is the concept. Right? Without the bounds, you would write down something like 0.01x cubed minus 1.25x squared plus 150x. And then you would add this constant, right? The constant of integration. Now, in this particular example, we know that constant of integration. That constant of integration is your starting cost, your fixed cost, $7,800. That's why that was provided to you. So now, this is C of x in general. So we want to know the cost of making 210 units. We were just going to plug in 210 into that function. You ended up getting $76,785 to make those units.